In this question, the unit vectors I and j are directed east and north respectively. A model boat sails from point P with an initial velocity of 2j meters per second. It accelerates uniformly to a velocity of -4i minus 6j meters per second in 12 seconds. A. Calculate the acceleration of the boat. B. The time in which the boat is travelling due west. After 6 seconds after leaving P, the boat is at Q with position vector -5i plus 2j meters. Find the position vector of P. So U is 2j, V is -4i minus 6i, and T is 12 seconds. So vector U, V, which is the final velocity, is equal to vector U plus AT. Therefore, -4i minus 6j is equal to the initial velocity, which is 2j, plus the acceleration vector times 12. So, collecting together the j components, we get -4i minus 8j is equal to 12a. So vector A will be 1/12 of -4i minus 6j. Taking the 12 in, we're going to get -1/3 I minus 2/3 of j. Using the idea that V is equal to U plus AT, then we have that V will be equal to 2j plus the acceleration, which is minus 1/3 I minus 2/3 j times t. So we're going to have minus 1/3 ti, and then we're going to have 2 minus 2/3 of t j. Now, if it was travelling due west, the j component would have to be, so the j component is this way, would have to be 0. So, and don't forget, velocity gives direction. So we got 2 minus 2/3 of t, because that has to be equal to 0, and then 2/3 of t is equal to 2, and therefore t is equal to 3 seconds. For the final part, we got that r is equal to ut plus a half at squared, where r is a displacement vector, plus the initial vector. So r in this case will be the displacement from this vector here. So we've got -5i plus 2j will be equal to u, which is 2j times the time, which is 6 in this case, plus a half times the acceleration, which is 1/3 I minus 2/3 j times 6 squared, plus the initial position up P, which we are being asked to find. So simplifying that, we're going to get 12j, and then doing a half times minus third times 36 will give me 6i, and then doing a half times minus 2/3 times 36 will give me 12j plus r0. The 12 and the -12 will cancel out, and if we take this here, we're going to get just I. So we're going to get r0 is going to be I plus 2j. So this has been a video to show you how to do kinematics using vectors. I hope you've understood, and I thank you very much for watching.